So first equilibrium, this is 3 mole, this is 3 mole, this is 9 mole. Therefore, K equal to Z concentration square divided by X2 concentration, Y2 concentration. So it will be 9 square divided by 3 into 3. You get 9, that is K. So first we need to find out equilibrium constant. We want to find degree of dissociation means first we need to work out what? Exactly. Equilibrium constant we need to find out. Hydrogen minus 1 and hydrogen here is plus 1. That is actually oxidized. So hydrogen undergo oxidation. Minus 1 to plus 1. So N factor will be 2. Please have a look at the question. Consider the following gaseous equilibrium in a closed container, volume V at T Kelvin, P2 plus Q2 giving 2 PQ, all are gases. 2 moles each of P2, Q2 and PQ are present at equilibrium. So 2 moles each of the 3 available at equilibrium. Now 1 mole each of P2, Q2 are added. To that equilibrium, we are adding 1 mole of P2 and Q2, keeping the temperature constant. Number of moles of P2, Q2, PQ at new equilibrium. So what is the old equilibrium? We have P2 plus Q2, you get 2 PQ. Okay. This is 2 mole, this is 2 mole, this is 2 mole. That is equilibrium quantity of P2, Q2 and PQ. And therefore you can get the equilibrium constant K equal to concentration of PQ square divided by concentration of P2 into Q2. That means 2 square divided by 2 into 2, you get 1. So equilibrium constant, we get 1. Okay. Now, the new scenario. The new scenario, 1 mole each of P2, Q2 added. So, new condition, 1 mole added. This 1 mole added, 1 mole added. This is also 1 mole added. So, the new situation will be 2 plus 1, 3 moles here, 3 moles here, and what is here? Here, what we have is 2 mole. So what will happen is some quantity will be converted to product. So we are adding P and Q. 1 mole each P and Q we are adding. So what will happen? Out of that 1 mole, it trying to attain a new equilibrium. Some quantity will be converted to product side. Let that quantity be X. Let that quantity be X. So X react. X react. Here you will get 2X. So here the quantity will be 3 minus X. 3 is available. X undergo conversion. 3 minus X at new equilibrium. 3 is available. X reacted to product sides. 3 minus X available in the new equilibrium. And 1 mole gave 2 mole. So here obtained will be 2X. So the new equilibrium quantity will be 2 plus 2X. 2 plus 2X. Okay. So here 3 becomes 3 minus X. 3 becomes 3 minus X. Here 2 becomes 2 plus 2X. Right. But remember, equilibrium constant remains same unless there is a same temperature. Okay. So what we can do now is, once again, this equal to PQ square, that is 2 plus 2X the whole square divided by P2 Q2, that is 3 minus X into 3 minus X equal to K equal to 1. That means 2 plus 2X divided by 3 minus X equal to 1. Isn't it? Taking square root on both sides. So that is equal to 1. That means you get 2 plus 2X equal to 3 minus X. that is x coming to this side, 3x equal to 1, 2 comes here, 3x equal to 3 minus 2, that is 1, x equal to 1 by 3, x equal to 1 by 3, that is 0.3333, that is x. Now what is our question? Number of moles of P2, Q2, PQ at a new equilibrium. So the quantity at a new equilibrium, it is 3 minus 0.33 something, that is here also 3 minus 0.33 something, and here it will be 2 plus 2 into 0.33, 2 into 0.33. That means option 4. That means option 4, the correct answer. 2.67, all 2.67. This will be 2.67. This will be 2.67. This will be 2.67. Okay. Fourth choice is the correct answer. I repeat, from the first data given, we find out equilibrium constant. And you know equilibrium constant remain constant at a particular temperature. Now we are adding PQ, P2 and Q2, 1 mole each extra. So this 2 becomes 3. Now from that extra quantity, some quantity converted to PQ. Let the quantity be x. So it will be 3 minus x. Here also 3 minus x. When x converted, you will get 2x. When x converted, you will get 2x. So here it will be 2 plus 2x. But this also you can write in equilibrium constant. Remember, this value remain fixed. Right? So 2 plus 2x the whole square by 3 minus x into 3 minus x, you will get 1. That is, take square root. 2 plus 2x by 3 minus x equal to 1, you get x. Once you get x, you get your answer. Once you get x, you get your answer. Because getting x, this is x, getting x, you are able to get the answer. Here it will be 3 minus x, 2 plus 2x. Fine. Yes. Next one. Consider two group 4 metal ions. Group 4 metal ion may be barium, strontium, calcium, right? Group 4 metal ions, X2 plus and Y2 plus. A solution containing 0.01 molar X2 plus and 0.01 molar Y2 plus is saturated with hydrogen sulfide. The pH at which the metal sulfide YS will form as a precipitate is. The pH at which the metal sulfide YS will form as a precipitate is nearest integer. Given KSP of XS, that of YS, so KSP of YS about which we are talking equal to concentration of Y2 plus into concentration of S2 minus, and that is equal to 4 into 10 power minus 16, and Y concentration available. So that is 0.01 into S2 minus equal to 4 into 10 power minus 16. Therefore, S2 minus concentration will be 4 into 10 power minus 40. This is S2 minus concentration. Okay. Now, considering this dissociation, H2S will dissociate giving HS minus plus H plus, and that further dissociate H plus plus S2 minus. Overall reaction will be H2S dissociate 2H plus plus S2 minus. This is Ka1, and this is Ka2 and this is Ka1 into Ka2, isn't it? So first step ionization H plus plus Hs minus. Second step ionization Hs minus again dissociate into H plus plus S2 minus. So this is Ka1, this is Ka2, this is overall Ka1, Ka2. So overall K equal to Ka1 into Ka2. Here you can see Ka1, Ka2 data is given. And that is equal to H plus concentration square into sulfide concentration divided by H2S concentration. And that is equal to Ka1 into Ka2. That is 10 power minus 21. This is equal to 10 power minus 21. That means H plus concentration square we don't know, from which we can get the pH, into sulfide concentration. We got sulfide concentration from here. That is 4 into 10 power minus 14 divided by H2S concentration 0.1, and that is equal to 10 power minus 21, isn't it? So what happens? 10 power minus 1, 10 power minus 14, it is minus 13. 10 power minus 13 with the 10 power minus 21, it will be 10 power minus 18, right? Sorry, 10 power minus 8. 10 power minus 8, isn't it? 10 power minus 8. So H plus concentration square, this 4 will come here. 1 by 4 means 0.25 into 10 power minus 8. That is 25 into 10 power minus 10. Therefore, H plus concentration, it is 5 into 10 power minus 5. 5 into 10 power minus 5. Therefore, what is pH? So what exactly will be pH? pH equal to negative logarithm of H plus concentration, negative logarithm of 5 into 10 power minus 5. That is 5 minus log 5. That is 5 minus 0.7. It will be 4.3. We want nearest integer, so the answer will be 4. Answer will be 4. 4 is the answer. Right? I'll repeat. From this data, we want to know at what pH YS precipitation will take place. So I'm taking YS KSP, from which I'm finding sulfide ion concentration. Agreed? Now, H2S Ka1 Ka2 data given. This is H2S Ka1 Ka2 equation. So equilibrium constant equal to Ka1 Ka2 equal to H plus square sulfide by H2S. This data we have just calculated. This data given in the question, and this data available in the question. So you can find out H plus concentration square. It will be 4 comes here. 1 by 4, 10 power minus 8 by mathematical calculation. So that is 25 into 10 power minus 10. That is H plus concentration square. And therefore H plus concentration will be root of this 5 into 10 power minus 5. Now pH equal to, very simple calculation, you get the answer. Okay, fine. Next. X2 gas, Y2 gas, 2Z gas. X2, Y2 are added to a 1 liter flask, and is found that the system attained above equilibrium with the number of moles X2, Y2 and Z being 339. Under this condition, equilibrium, 10 mole Z is added to the flask and the temperature is maintained. So that means temperature when maintained means there is no change in equilibrium constant data. Then the number of moles of Z in the new equilibrium. It's a similar question. similar to the other one we did. So it is x2 plus y2, you get 2z, all are gases. So first equilibrium, this is 3 mole, this is 3 mole, this is 9 mole. Therefore, K equal to Z concentration square divided by x2 concentration, y2 concentration. So it will be 9 square divided by 3 into 3. You get 9, that is K, isn't it? This is equilibrium constant K. Now we are adding 10 mole of Z. We are adding 10 mole of Z. Here we are adding 10 mole of Z added. So the new quantity will be 9 plus 10, 19. 19. Here it is 3, 3. Now what will happen is, since you have added something here, the equilibrium will be shifting to left side. So out of 19, let some quantity converted to this side. That means, suppose 2x quantity converted to this side. So the remaining quantity 19 minus 2x. 2x for the convenient purpose only, because 2 mole will give you 1 mole, 1 mole. 2x when converted. 2x when converted. Imagine from here 2x converted to this side. It will be x and x. So here it is x added. So 3 plus x on this side and 3 plus x on this one. So when 2x quantity converted to left, out of that extra 10 mole added. Out of that extra 10 mole added, imagine 2x quantity converted to left side. So the remaining quantity for Z will be 19 minus 2x. When 2 mole react, you get 1 mole. When 2x react, you get x. Here it will be 3 plus x, 3 plus x. Now again, substituting on the equilibrium constant, you get K, Z value. It is 19 minus 2x the whole square divided by 3 plus x into 3 plus x. That is equal to 9. Take square root on both sides. You get 19 minus 2x divided by 3 plus x equal to 3 in the gittum. That means 19 minus 2x equal to, here there is a mistake, 3 plus x. 3 into 3 plus x. So it is 19 minus 2x is equal to 9 plus 3x. Isn't it? So 9 comes this side. 19 minus 9 equal to 3x minus 2x. That is 10 equal to 9 plus 3x. Yes, 10 equal to isn't it? Any mistakes happened? 3. 19 minus 2x equal to 3 into 3 plus x. Right? 3 into 3, 9 plus 3 plus x. So when this come to this side, 5x, isn't it? Plus. Some mistake happened. So 19 minus 9 equal to 3x plus 2x, you get 5x. Therefore, x is equal to 10 by 5, you get 2. What we need to find out? The number of moles of Z in the new equilibrium. Number of moles of Z in the new equilibrium. This is the number of moles of Z in the new equilibrium. So it is 19 minus x equal to 2. So it is 19 minus 2 into 2. 19 minus 4, 15 is the answer. Answer is 15. 15 is the answer. A similar question to the other one we did. Question number 35. We have a gas phase equilibrium given. This is the reaction. NH3 gas giving half N2 gas plus 3 by 2 H2 gas. Total pressure given √3 atm at equilibrium, and equilibrium constant Kp given 9. The question is, what is degree of dissociation? Degree of dissociation, we need to find out alpha, which is given as x into 10 power minus 2 whole raised to half. What is x? That is the question. So let's try to figure out. It is ammonia gas giving half N2 gas plus 3 by 2 H2 gas. Okay. Starting with 1 mole, here 0. So here it is 1 minus alpha. Here you will get alpha by 2. Here you will get 3 alpha by 2. Right? So n total will be 1 minus alpha plus alpha by 2 plus 3 alpha by 2. You get 1 plus alpha. Here is minus alpha, 0.5 alpha, 1.2 alpha. So it is 1 plus alpha. This is n total. Now we can relate Kp equal to, Kp given as 9 equal to pressure of N2 raised to half into pressure of H2 raised to 3 by 2 divided by pressure of ammonia. And pressure, mole fraction into total pressure, mole fraction of nitrogen, number of moles divided by N total. So it is alpha by 2 by 1 plus alpha into total pressure root 3 into root 3 raised to half. Okay. Aduthathu pressure of hydrogen, that will be 3 alpha by 2. 3 alpha by 2 divided by 1 plus alpha into root 3 raised to 3 by 2. Right? Divided by 1 minus alpha. 1 minus alpha by 1 plus alpha. 1 plus alpha into root 3. This is what the substitution. Now alpha raised to half, alpha raised to 3 by 2, that will be alpha square. Now root 3 raised to half, root 3 raised to 3 by 2, that will be root 3 square. പിന്നെ ഇവിടെ ഒരു 3 raised to 3 by 2 ഉണ്ട് കേട്ടോ, 3 raised to 3 by 2, ശരിയല്ലേ? ഡിവൈഡഡ് ബൈ ഒരു 2 raised to half, 2 raised to 3 by 2, 2 raised to 2, പിന്നെ 1 plus alpha raised to half, raised to 3 by 2, 1 plus alpha the whole square, divided by 1 minus alpha by 1 plus alpha into root 3 എന്ന് വരും അല്ലേ? ഒന്നും മിസ്സായിട്ടില്ലല്ലോ? റൈറ്റ്. നോ വാട്ട് യു ഗെറ്റ് ഈസ്, ഈ ഒരു 1 പ്ലസ് ആൽഫ ഒരെണ്ണം ക്യാൻസലായി, റൂട്ട് 3 ഒരെണ്ണം ക്യാൻസലായി അല്ലേ? ആൻഡ് ഹിയർ യു ഹാവ് റൂട്ട് 3 raised to half, 3 raised to 3 by 2 അല്ലേ? റൂട്ട് 3 raised to half and 3 raised to 3 by 2. Sorry, root 3 raised to half അല്ല, 3 raised to half. അപ്പോൾ 3 raised to half-ഉം 3 raised to 3 by 2. അപ്പോൾ ഇതെന്തായി മാറി? ഇത് 3 സ്ക്വയറായി, 3 സ്ക്വയർ. അപ്പോൾ ഈ 3 സ്ക്വയറും ഈ 9ഉം നമുക്ക് ക്യാൻസൽ ചെയ്യാം, ശരിയല്ലേ? അപ്പോൾ അത് ക്യാൻസലായി. സോ വി ഗെറ്റ് ഈക്വൽ ടു 1 എന്ന് കിട്ടും. ഈ 9ഉം ദിസ് 3 raised to half, 3 raised to 3 by 2 become 3 square, cancel. And now what you have left with is alpha square ഉണ്ട്, പിന്നെ alpha square ഉണ്ട്, divided by ഒരു 4 ഉണ്ട്, 1 minus alpha square, 1 plus alpha-യും 1 minus alpha-യും, 1 plus alpha square, right? So that you get 4 into 1 minus alpha square equal to alpha square. 4 minus 4 alpha square equal to alpha square. 4 equal to 5 alpha square എന്ന് കിട്ടും. Therefore, alpha square equal to Therefore, alpha square equal to 4 by 5 എന്ന് കിട്ടും കേട്ടോ. നമുക്ക് വേണ്ടത് ആൽഫയാണ്. So, alpha equal to 4 by 5 raised to half എന്ന് എഴുതാം. അതിനെ നമുക്ക് ഇവിടെ ഇക്വേറ്റ് ചെയ്യാം. The degree of dissociation given as x into 10 power minus 2 raised to minus half ആണ് equal to x into 10 power minus 2 raised to minus half ആണ്. എന്ന് വെച്ചാൽ ഇങ്ങനെ എഴുതാം. 4 by 5 raised to half equal to 1 by x into 10 power minus 2 raised to half. ഇങ്ങനെ എഴുതാം. അപ്പോൾ റൂട്ട് അങ്ങോട്ട് പോകും. You get 4 by 5 equal to 1 by x into 10 power minus 2. Therefore, x equal to 5 by 10 power minus 2 into 4 എന്ന് വരും. അപ്പോൾ 10 power minus 2 മുകളിലേക്ക് പോയാൽ 500 by 4 എന്ന് വരും. 125 എന്ന ആൻസർ കിട്ടും. x equal to 125 എന്ന ആൻസർ കിട്ടും. That is the final answer. 125. That is the final figure. Okay. ഞാൻ ഒന്നുകൂടെ പറയാം. This is the equilibrium we have, and equilibrium pressure given and equilibrium constant is given. Okay. Now, starting with 1 mole ammonia, you have 0 nitrogen, hydrogen. Suppose alpha is degree of dissociation, 1 minus alpha, quantity of nitrogen, ammonia at equilibrium, and nitrogen will be, 1 mole give half mole, x will give you x by 2. You get x by 2 nitrogen, and ഇവിടെ 3 by 2 ആണ്. അപ്പോൾ 3x by 2 എന്ന് വരും. I mean 3 alpha by 2 എന്ന് വരും. So, ammonia quantity at equilibrium 1 minus alpha, nitrogen quantity alpha by 2, hydrogen quantity 3 alpha by 2. So, total number of moles it will be 1 minus alpha plus alpha by 2 plus 3 alpha by 2, 1 plus alpha എന്ന് കിട്ടും. Right? Now, Kp given 9 equal to partial pressure of nitrogen raised to half into partial pressure hydrogen raised to 3 by 2 by partial pressure ammonia. Everybody remember, partial pressure of a gas equal to mole fraction of that gas into total pressure. So, partial pressure of nitrogen എന്ത് ചെയ്യണം? Mole fraction of nitrogen, number of moles of nitrogen alpha by 2 ആണ്. Total number of moles 1 plus alpha ആണ്. So, alpha by 2 by 1 plus alpha root 3 pressure, total pressure at equilibrium, root 3 raised to half. On to hydrogen, 3 alpha by 2 by 1 plus alpha root 3 whole raised to 3 by 2 എന്ന് വരും. താഴത്ത് അമോണിയയുടേത് 1 minus alpha by 1 plus alpha into root 3 എന്ന് വരും. Many times we have continuously practicing this kind of exercise, right? Now, simplify ചെയ്ത് കഴിഞ്ഞാൽ ഇത് കെയർഫുൾ ആയിട്ട് സിംപ്ലിഫൈ ചെയ്യാം. സിംപ്ലിഫൈ ചെയ്താൽ യു വിൽ ഗെറ്റ് 1 equal to, ഇവിടെ ഒരു 9ഉം ഇതൊക്കെ ക്യാൻസൽ ആവും. So, you get 1 equal to alpha square by 4 into 1 minus alpha square എന്ന് കിട്ടും. ഇത് സിംപ്ലിഫൈ ചെയ്യുന്നത് ശ്രദ്ധിക്കണം കേട്ടോ. So, that will take you to alpha square equal to 4 by 5 എന്ന് കിട്ടും. Right? Therefore, alpha equal to 4 by 5 raised to half എന്ന് കിട്ടും. അതിനെ ഇതിൽ വെച്ച് ഇക്വേറ്റ് ചെയ്യാം. Right? Equal to x into 10 power minus 2 raised to minus half ആണ് കേട്ടോ. Minus half ആണ്. അപ്പോൾ 1 by എഴുതുക. അപ്പോൾ ഹാഫ് അങ്ങ് ക്യാൻസൽ ആയി. So, you get 4 by 5 equal to 1 by x raised to 10 power minus 2 എന്ന് കിട്ടും. You get x as 125. Okay? I think that is pretty clear. അടുത്ത ചോദ്യം. Question number 36. Consider the general reaction given below at 400 Kelvin. XA gas giving YB gas. The values of Kp, Kc are studied under the same condition of temperature but variation in x and y. X and y മാറ്റിയിട്ട് Kp, Kc വർക്കൗട്ട് ചെയ്തിട്ടുണ്ട്. അപ്പോൾ കേസ് 1, കേസ് 2, Kp, Kc തന്നിട്ടുണ്ട്. Value of x and y in 1 and 2 respectively are. Choice നോക്കുക. 4, 1, 1, 4 like that. 1, 2, 2, 1 like that. That means ഇപ്പോൾ ചോയ്സ് 1 ആണെന്ന് വിചാരിക്കുക. X equal to 4. That means 4A gas giving 1B gas. That means del n equal to 1 minus 4, 3 എന്ന് കിട്ടും. നേരെ തിരിച്ച് രണ്ടാമത്തെ ചോയ്സ് ആണെങ്കിലോ, this is case 1. This is case 1. ഇനി case 2 ആണെങ്കിലോ, it is 1A gas giving 4. this should be wrong. It may be like varying 4-1 4-1 എന്നാവില്ല. 4-1 4-1 ആണെങ്കിൽ ഇവിടെ സെയിം വരണ്ടേ? അങ്ങനെ ആയിരിക്കില്ല, ഇവിടെ 1-4 എന്നായിരിക്കാം ചിലപ്പോൾ കേട്ടോ. അങ്ങനെയാണെങ്കിൽ 1ഉം 4ഉം 4ഉം. സോ ഡെൽറ്റ എൻ വിൽ ബി 4 minus 1 3 എന്നായിരിക്കാം. ഇവിടെ -3, സോറി, ഇവിടെ -3ഉം ഇവിടെ 3ഉം. അപ്പോൾ ഈ കോമ്പിനേഷനിൽ അതായിരിക്കാം ഉദ്ദേശിച്ചത് കേട്ടോ. കാരണം KPKC ഡിഫറെൻ്റ് ആയിട്ടാണ് വരുന്നത്. ഡെഫിനറ്റ്ലി ഈ കോമ്പിനേഷൻ, ഒരേ കോമ്പിനേഷൻ വന്നു കഴിഞ്ഞാൽ KPKC സെയിം അല്ലേ വരുള്ളൂ, റൈറ്റ്? സോ ദിസ് മേ ബി ഈ ചോയ്സ്, ദിസ് മേ ബി എ റോങ് ഓർ ഇൻവാലിഡ് ചോയ്സ് ഇറ്റ് സീംസ്. ഇത് ഓക്കെയാണ്. 1 2 2 1 1 3 1 3 2 1, നോ പ്രോബ്ലം. ഡിഫറെൻറ്റ് കോഎഫിഷ്യൻ്റ് ആയിരിക്കണം. ഇറ്റ് ഷുഡ് ബി സെയിം കോഎഫിഷ്യൻ്റ്. ഹൗ ക്യാൻ യു ഗെറ്റ് KPKC? Because what is the relationship? What is the relationship? Kp equal to Kc RT power delta n എന്നാണ്. That means Kp by Kc equal to RT power delta n. Suppose 2 delta n are same, KP-Kc relation, KP-Kc ratio should come same, no? This is not found to be the same ratio. 85.87 by 2.5. ഒരു നിയർലി 30-32 എന്ന് വരും. 0.8 by 28.67. ഡെഫിനറ്റ്ലി ഇറ്റ്സ് എ ഡിഫറെൻറ്റ് ഫിഗർ, ഹൈലി ഡിഫറെൻറ്റ് ഫിഗർ. അപ്പോൾ ഒരിക്കലും ഒരേ കോഎഫിഷ്യൻസ് വരില്ല. ഇത് മാറിപ്പോയതായിരിക്കും മേ ബി, റൈറ്റ്? So what can be done? Let us find out KP-Kc ratio and let us find out RT value also. അപ്പോൾ ഫസ്റ്റ് ചോയ്സ് ആണ് എടുക്കുന്നത് എങ്കിൽ, സപ്പോസ് ഇറ്റ് ഈസ് അസ്യൂമിങ് 4-1 ആൻഡ് 1-4, ഇങ്ങനെ അസ്യൂം ചെയ്താൽ ഫസ്റ്റ് കേസ് 4-1 ആണെങ്കിൽ ഇവിടെ 4 ഇവിടെ 1, സോ ഡെൽറ്റ എൻ വിൽ ബി -3. സെക്കൻഡ് കേസിൽ 1ഉം 4ഉം ആണെങ്കിൽ ഡെൽറ്റ എൻ വിൽ ബി +3. ഓക്കെ, so we can find out RT, this value we can figure out. R given, we can take appropriate units. So R 0.08 into temperature 400 raised to 3 or raised to -3, raised to -3. When you work out, you can see it may come around, please verify, 0.0003 range, nearly ആ റേഞ്ചിലായിരിക്കും കിട്ടും. Meanwhile, that I am talking first case, first option, first case. Now about second case, it will be 0.08 into 400 power 3, right? അപ്പോൾ ഇത് ചെയ്ത് കഴിഞ്ഞാൽ എന്നാൽ 32 raised to 3, നിയർലി എബവ് 30,000, നിയർലി എബവ് 30,000, ഒരു 32,000 സംതിങ് ആ റേഞ്ചിലാണ് വരിക. മനസ്സിലാവുണ്ടോ? സോ ഐ എം ചെക്കിംഗ് ദ ഫസ്റ്റ് ഓപ്ഷൻ വേർ ഇറ്റ് ഈസ് 4114 or 1441, വാട്ട് എവർ ഇറ്റ് ഈസ്. അപ്പോൾ ഇവിടെ കോഎഫിഷ്യൻ്റ് 4ഉം ഇവിടെ കോഎഫിഷ്യൻ്റ് 1 വന്നു കഴിഞ്ഞാൽ -3, ഡെൽറ്റ എൻ -3 വരും. 1-4 വന്നു കഴിഞ്ഞാൽ 3 വരും. സോ ലെറ്റ് us check for the coefficient delta according to the coefficients delta n 3 or -3. This is the figure that we can cross check here. For example, first one, Kp by Kc 85.87 divided by 2.587. This is nearly 32. First case. Suppose I'm considering, assuming these two are inverted. 1-4-4-1. Suppose it is 1-4 and 4-1. So matching with this, see, 32 and 30,000. Anyway, these two values are never matching with this. Now let's take the second case. it is 0.862 divided by 28.62. That will come nearly 0.03. Anyway, 1 and 2 figures, you see the values nearly, I'm talking nearly. So when you take the first one, Kp by Kc, you are getting nearly some 32, 33 range. Second one, when you take Kp by Kc, you are getting nearly 0.03. That means this is not matching with the 4-1 values. Maybe the choice it is 4114 values, it is not matching. Okay. What about the second choice? 1 and 2, 2 and 1. 1 and 2, 2 and 1. Suppose you take that coefficient, I mean the second choice. Maybe in the first case it is 2, sorry, it is 1 and 2. 1a giving 2b, therefore delta n equal to 2 minus 1, 1. And the second case, it is 2a giving b, therefore delta n is equal to 1 minus 2, minus 1. അപ്പോൾ ഇവിടെ വരുന്നത് 2 1 minus 1 ആണ് വരിക, 1 minus 1 ആണ് വരിക, right? What will be the scenario for delta n? See, this is fixed. This is fixed. This we need not cross check. The what value changes is delta n. So I am taking delta n first case RT power delta n. That will be 0.08 into 400 power 1. 0.08 and 400 to 1 and 2. 1 and 2. So it is raised to 1. It is 8 into 4, isn't it? 8 into 4, nearly 32. So that is matching. That is matching. Nearly 32. In a തിരിച്ചാണെങ്കിൽ second case ആണെങ്കിൽ second case RT raised to minus, sorry, RT raised to delta n 0.08 into 400 raised to minus 1 എന്ന് വെച്ചാൽ 1 by 32. 1 by 32 is nearly 0.03. ശരിയല്ലേ? 1 by 32 is nearly 0.03, isn't it? 1 by 30 is 1 by 30, 1 by 3 is 0.3, 1 by 30 0.033 something, 1 by 32 0.03 nearly എന്ന് കിട്ടും. അപ്പോൾ അതും മാച്ചിങ് ആണ്. So the correct answer is second choice. Correct answer is second choice, and let me tell you, option 1 as it is given, option 1 and option 3, it is not seem to be valid. കാരണം ഒരേ കോഎഫിഷ്യന്റ് വരുന്ന കേസ് അല്ല ഇവിടെ കാണുന്നത്. Because when you take the ratio Kp by Kc, you are getting different values. That means the coefficients are different. Because Kp by Kc is equal to, ഇവിടെ നോക്കിയാൽ അറിയാലോ, Kp by Kc is equal to RT power delta n അല്ലേ, right? So Kp Kc, if Kp by Kc, if you get different value, that means delta n is different. So two situations, Kp by Kc, if you get different value, that means delta n should be different. No doubt about it. For delta n to be different, it cannot be like this. So I am assuming this is 1441 like that. This is 1331 like that. This is okay, different. This is also different. Anyway, we got the answer. Second choice is the correct answer. 1221. If it is 1 2, 1 here, 2 here, so delta n will be 2 minus 1, 1 എന്ന് കിട്ടും. And second case 2 1, 2 here, 1 here, delta n will be 1 minus 2, minus 1 എന്ന് കിട്ടും. And when you figure out first case Kp by Kc 85.87 by 2.5, you are getting nearly 32. And 0.86 divided by 28.62, you get nearly 0.03 എന്ന് കിട്ടും. Okay. Now coming to that calculation over here, you get RT power delta n. with the 1 and minus 1, you get nearly 32.03, and that will be the perfect match. If you take up, suppose it is 1441, what you are getting is you will get minus 3 and plus 3. If it is plus 3, it is coming in the range of more than 30,000. Never match with the ratio. If it is 10 power minus 3, it is coming 0.0003 something. That's a very low figures. Okay, that also is not matching with the conditions of Kp by Kc. So the suitable answer should be 1 and 2, 2 and 1. Okay, fine. Next. Which of the following mixtures gives a buffer solution with the pH equal to 9.25 given pKb of ammonium hydroxide 4.75? So we are talking about a basic buffer. So what is the equation for basic buffer? For basic buffer, POH is equal to pKb plus log concentration of salt by concentration of base. That is the Henderson equation. You know that. ഇവിടെ തന്നിരിക്കുന്നത് pH ആണ്. So POH will be 14 minus pH equal to pKb plus log concentration of salt by concentration of base. അപ്പോൾ 14 minus 9.25 equal to 4.75 plus log concentration of salt by base. 14 minus 9.25 എന്ന് പറയുമ്പോൾ 4.75. 4.75 equal to 4.75 plus log salt by base. So the matter is very simple. Log salt by base equal to 0. That is salt by base equal to 1, isn't it? So pH given 9.25, therefore POH will be 14 minus pH, you get 4.75. That is equal to pKb given in the question, 4.75. So that means log salt by base is equal to, ഇത് അങ്ങോട്ട് പോയി കഴിഞ്ഞാൽ 0 എന്ന് കിട്ടും. Log salt by base is equal to 0. Log of any value 0 means you know that value will be 1. So it is salt by base equal to 1. So the point is ഇവിടെ salt ammonium chloride ആണ് കിട്ടും. Ammonium hydroxide with HCl. So it is ammonium chloride concentration by ammonium hydroxide concentration equal to 1. That means ammonium chloride concentration equal to ammonium hydroxide concentration. This is what our point. So in which case that is possible? ഇതാണ് ചോദ്യം. Suppose I am taking first case. We have ammonium hydroxide with HCl. You get ammonium chloride and water. Suppose I am taking first case, 0.2 molar, 0.4 liters. So this is molarity into volume in liter. Number of moles equal to molarity into volume in liter. So here it is 0.2 into 0.4. എന്ന് വെച്ചാൽ 0.08 mole. കേട്ടോ? ഇനി HCl it is 0.1 into 1, that is 0.1 liters. That means this is the limiting reactant. Sorry, 0.1 mole. 0.1 mole. That means this is the limiting reactant. Here, this is the limiting reactant. That means this is completely consumed. This is completely consumed and it is converted to ammonium chloride. Ammonium chloride formed is 0.8 mole. And you don't have base remaining and that cannot act as a buffer. ഒന്നാമത്തെ കേസ് ബഫറേ അല്ല. കാരണം the entire ammonium hydroxide has neutralized. Ammonium hydroxide is the limiting reactant. Ammonium hydroxide is the limiting reactant and it is entire converted to ammonium chloride. Okay. We want buffer. We want buffer. In fact, first choice will not make a buffer. Now on to the second choice. How the second choice works, let's see. It is 0.2 molar, 0.5 liter. So it is 0.2 into 0.5, that is 0.1 mole. ഇതാണ് ammonium hydroxide. And here it is 0.1, 0.5. 0.1 into 0.5, that is 0.05 mole, that is HCl. This can make a buffer. This can make a buffer. Because here, this is the limiting reactant. Here, this is the limiting reactant. And that is completely consumed. So the amount consumed is 0.05. Here, amount consumed is 0.05. Right? So 0.1 mole available, 0.05 consumed. What remaining is 0.05 mole remaining. Now 0.05 mole react. That means ammonium chloride will be 0.05 mole. And in fact, this is our answer. Second choice is our answer. Why? Because in that case, we get the ammonium hydroxide remaining. Ammonium hydroxide remaining, it is 0.05. And ammonium chloride formed, it is 0.05. So the quantity of salt formed is equal to quantity of base remaining. That means we satisfy this condition. So this condition is satisfied and forming an excellent buffer in option 2. How do we understand? Because ammonium hydroxide quantity 0.2 into 0.5, 0.1 molar, and HCl quantity 0.1 into 0.5, 0.05 molar. It's very easy to understand. They react 1:1 mole ratio. So 0.05, this is the limiting reactant which is completely consumed. How much? 0.05. Okay. How much base available? Taken 0.1. How much react? 0.05 react. How much remain? 0.1 minus 0.05, 0.05 remain. Okay. Now 1 mole base will give you 1 mole salt. So 0.05 mole ammonium hydroxide, you get 0.05 mole ammonium chloride. Now you can verify the salt formed quantity is equal to the base remaining quantity. That means they come equal and satisfy our condition. Option 2 is the perfect answer. Is that clear? Is that clear? Fine. Next question. 38. Dissociation of a gas A2 takes place according to the following chemical reaction. At equilibrium, the total pressure is 1 bar at 300 Kelvin. A2 gas giving 2A gas. The standard Gibbs energy of formation involved in the substances are provided below. We want to find out degree of dissociation again. Degree of dissociation is equating as like we did earlier, x into 10 power minus 2 raised to half. What is x? So first we need to find out equilibrium constant. We want to find degree of dissociation means first we need to work out what? Exactly. Equilibrium constant we need to find out. How to find equilibrium constant? It is available as delta G is given. Delta G is given for the reaction A2 gas giving 2A gas. The delta G values are given. Sorry. Delta G formation values are given. A2 in the value minus 100 kilojoule. In the value minus 50.832 kilojoule. So you know what will be the delta G reaction. So delta G reaction is equal to sum of delta G products minus sum of delta G reactants. So this minus this. Upon minus 50.832 into 2, that's very important, minus 100. എത്ര വരും? 2, 6, 16, 1, 5 അല്ലേ? ഇത്രയും. സോറി 16, 1, 2, 10 ഇത്രയും. മൈനസ് 101.64 കേട്ടോ. 62 അല്ല, 64 4, 6, 16. ഓക്കെ ഫൈൻ. പ്ലസ് 100 എന്ന് ചെയ്താൽ എന്ത് വരും ഇവിടെ? ഇറ്റ്സ് മൈനസ് 1.664, isn't it? Minus 1.664, right? അത്രയും kilojoules. അത്രയും kilojoules. Now we can find out equilibrium constant K. What is the formula? Delta G not equal to minus 2.303 into RT log K. അല്ലേ? So that will be minus 1.664 equal to minus 2.303. R 8.3 എന്ന് കൊടുക്കാം, അല്ല, ഇൻറ്റു 10 പവർ മൈനസ് 3 എന്ന് കൊടുക്കാം, അല്ലേ? ഇൻറ്റു ടെമ്പറേച്ചർ ഗിവൺ 300. So 300 into log K. Therefore, log K equal to 1.664 divided by 2.3, 8.3 into 10 power minus 3 into 300. Right? അപ്പോൾ ഇവിടെ ഒരു 300 ക്യാൻസൽ ചെയ്യുമ്പോൾ 3 എന്ന് വരും. ഇവിടെ ഒരു 10 പവർ മൈനസ് 1 വരും. നമുക്കത് മുകളിലേക്ക് എടുത്താൽ 16.64 ഡിവൈഡഡ് ബൈ 2.3 ഇൻറ്റു 8.3 ഇൻറ്റു 3 എന്ന് വരും, അല്ലേ? ഇത് നിയർലി 2. ഇത് ക്യാൻസൽ ആയാൽ 1/3 എന്ന് പറയുമ്പോൾ 1/3 എന്ന് പറയുമ്പോൾ ഒരു 0.3 റേഞ്ചിൽ കിട്ടും. That means K you will get it as 2. K you will get it as 2. You can verify. K you will get it as 2. K. You can verify that. I just made a rough calculation, but that itself is leading to 0.3 range value, and we know log K equal to 0.3 if it comes. Log K, if it is coming 0.3, we can understand K equal to 2 because log 2 is equal to 0.3010, correct? Now that's okay. Once you get K, we can go for the calculation consent. What calculation? A2, you get 2A. Starting with 1 mole, ഇവിടെ 0, 1 minus alpha, ഇവിടെ 2 alpha. And N total will be 1 plus alpha. Therefore, K equal to 2 pressure of A square divided by pressure of A2. അല്ലേ? That is 2 alpha by 1 plus alpha into total pressure. Total pressure is 1 bar, so need not give. Whole square divided by 1 minus alpha by 1 plus alpha. 1 minus alpha by 1 plus alpha. So you get K equal to 2 equal to 4 alpha square by 1 minus alpha square. Many times we did this. 2 alpha square, 4 alpha square, 1 plus alpha square, 1 minus 1 plus alpha square. ഇവിടെ ന്യൂമറേറ്ററിൽ ഇവിടെ 1 plus alpha square വരും. ഇവിടെ 1 minus alpha by 1 plus alpha. അപ്പോൾ ഒരെണ്ണം ക്യാൻസൽ ആവും. സോ ഇറ്റ് ഈസ് 1 plus alpha into 1 minus alpha, 1 minus alpha square എന്ന് കിട്ടും. So 2 equal to 4 alpha square by 1 minus alpha square. That means 2 minus 2 alpha square equal to 4 alpha square. That is 2 equal to 6 alpha square. That is alpha square is equal to 2 by 6. That is 1 by 3. Alpha square equal to 1 by 3 and alpha equal to 1 by 3 raised to half. Okay. അത് ഇവിടെ equate ചെയ്യാം. That is 1 by alpha equal to 1 by 3 raised to half equal to x into 10 power minus 2 raised to half. നേരത്തെ ഒരു ക്വസ്റ്റ്യനിൽ കണ്ട് ഇവിടെ മൈനസ് ഹാഫ് ആണ്, ഇപ്പോൾ ഹാഫ് ആണ്. That means 1 by 3 equal to x into 10 power minus 2. Therefore, x equal to 10 power minus 2 അപ്പുറത്തോട്ട് പോവും, 10 power 2 ആവും. 100 by 3, you get 33 as the answer. You get 33 as the answer. Final answer 33. I'll repeat. Once again, we need to find out degree of dissociation alpha. That is expressed as x into 10 power minus 2 whole raised to half. Okay. So finding alpha, this will be the procedure. Finding alpha, this will be the procedure for which we need to know what is k. How to get k? K can be calculated if you know delta G. So to get k, we need delta G. How to get delta G? Delta G for A2 and A are given. Delta G for A2 and A are given. For A2 minus 100, for A minus 50.832. Never try to round it off. Never try to round it off. Now for the reaction A2 giving 2A, delta G formation, individual substances are given. Therefore, total delta G reaction equal to sum of delta G products minus sum of delta G reaction. We know that. So it will be that of product 50.832 into 2 minus 100. So that will be, when worked out, minus 101.664 plus minus of minus 100. So you get minus 1.664 kilojoule. That is delta G of reaction. That when substituted here, you will get K. Log K you are getting in the range of 0.3. Therefore, K equal to 2 എന്ന് കിട്ടും. K equal to log K equal to 0.3 means log of 2 is 0.3, we know. So K equal to 2 എന്ന് കിട്ടും. Once you get K equal to 2, you can go to this side. Starting with 1 mole 0, 1 minus alpha, it will be 2 alpha here. So the formula will be K equal to 4 alpha square by 1 minus alpha square. Many times that particular stoichiometry we have encountered. Okay. So from that you are getting alpha square equal to 1 by 3 എന്ന് കിട്ടും. Alpha equal to 1 by 3 raised to half. ഇവിടെ equate ചെയ്യാം. You get easily what is x. Question number 39. The first and second ionization constants of H2X given as 2.5 into 10 power minus 8 and 1 into 10 power minus 30. So this is Ka1 and this is Ka2. The concentration of X2 minus in 0.1 molar H2X solution 10 into dash into 10 power minus 50 nearest integer. Okay. So it is H2X will give you H plus plus HX minus. Starting with 1 mole 0 0. Suppose X is the degree of dissociation. 1 minus X. Here it will be X. Here it will be X. Okay. That is first dissociation, Ka1. Now the next dissociation, Hx minus, will give you H plus plus X2 minus. That is second ionization, where the quantity of Hx minus starting is 0 x, this will be 0, this quantity. Now imagine the degree of dissociation is y, then this will be x minus y, x quantity from here, and 0 0, and at equilibrium let the dissociation be y quantity, so x minus y, here it will be y and here it will be y. Now actually the two equilibrium are under simultaneous condition. So what we can understand is this will be x plus y, because h plus x quantity from this case and y quantity from this case, this will be x plus y, because they are available under simultaneous equilibrium. Similarly, these two are under simultaneous equilibrium. This will be x minus y and this will be x minus y. Those species available in simultaneous equilibrium, their quantity will remain equal. Okay. So I repeat, 1 mole here, 0, 0, x converted, you get 1 minus x, x, x. And this x will dissociate further, y quantity dissociated, x minus y, and here it is y, y, and here x, here y, so it is total h plus will be x plus y, okay, and hx will be x minus y, right? Now it is very much evident that this value is a very low value. So we can assume Ka1 is greater than Ka2. This is in the range of 10 power minus 8. This is in the range of 10 power minus 13. Obviously, x will be greater than y. So y is negligible compared to x. We can proceed. Okay. So what we can do is Ka2 equal to, we want to find the concentration of X2 minus. We want to find the concentration of X2 minus. So Ka2, this is Ka1, this is Ka2. Ka2 is equal to H plus concentration into X minus concentration divided by Hx minus concentration. That is equal to 10 power minus 30 given. And that is equal to x plus y into y by x minus y. And that can be written as x into y by x, because x plus y is nearly x, x minus y is nearly x, because y is negligible compared to x. Is it clear? So that means you get the answer. This is equal to y. Y is nothing but concentration of x2 minus. So this is nothing but concentration of x2 minus. That is 10 power minus 30. So concentration of x2 minus equal to 10 power minus 13 equal to dash into 10 power minus 50. So it is 100. The answer is, final answer is 100. 100 into 10 power minus 50. Final answer will be 100. Right? I repeat, the two-way dissociation. First one Ka1, it's dissociating like this. Second two Ka2, it's dissociating like this. So here, suppose x dissociates, you get 1 minus x, 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 and that x undergo dissociation here. Suppose y dissociate, x minus y and y, y, and this is x here and y here. So it is simultaneous equilibrium x plus y. Okay, now we want to get this. So I am taking Ka2, Ka2 equal to this, which can be written like this. Now the point is Ka1 is much higher compared to Ka2, or Ka2 is very negligible compared to Ka1. That means the second degree of dissociation is very negligible compared to first degree of dissociation. So Y is negligible compared to X. When you apply that, you get the concentration of X2, that is Y value you get comfortably. Okay, that's it. അടുത്ത ചോദ്യം. Use the following data. 1 mole each of A2, B2 are taken in 1 liter closed flask and allowed to establish equilibrium at 500 Kelvin. Equation available. We want to know the value of X in kilojoule per mole. Value of X in kilojoule per mole. That means we need to get this data. There is a X in the, that means we need to get the enthalpy formation for B2. Enthalpy formation for B2 we need to find out. So how can we get that? All of you know delta H reaction equal to sum of delta H formation products minus sum of delta H formation reactants, right? And that is equal to product AB. So it is delta H AB into 2 minus delta H AB is available here 32 minus delta H delta H for A2 plus delta H for B2. This value available in the question. This value available in the question given 32. This value available in the question 6. This is what we need to find out. So that means if you want to get this, you need to know what is this. You need to get enthalpy of reaction. Fine. So to get enthalpy formation of one of the reactant, that is B2, you must know what is enthalpy of reaction. That you can get. If you get this, you get this. To get that, you can apply the equation. What equation? Delta G equal to delta H minus T delta S. Therefore, delta H is equal to delta G plus T delta S. Isn't it? Delta G equal to delta H minus T delta S, Gibbs equation, and delta H is equal to delta G plus T delta S. And what about T delta S? T delta S we can calculate. T delta S. How? How to calculate delta S? Delta S equal to sum of delta S products minus sum of delta S reactants, isn't it? Into T. What is delta S? Delta S product, that is AB. This is delta S product. So it is 222 into 2. 222 into 2 minus 146 into 1 and 280 into 1. So it is 146 plus 280. Isn't it? That will be 6, 2, 3 plus 1, 4. So you get this much. While here 222 into 2, that is 444. So it is 444 minus 426. 8 6 14 3 1. It is 18. You get 18. This is delta S. Delta S you get 18. So what is T delta S? T delta S will be temperature given 500. So it is 500 into 80. All this in joules. Remember that. Okay. So it is 990, 9,000. 9,000 will be value T delta S, 9,000. Now we need to get delta G. Delta G. So now T delta S is over, it is 9,000 joules. Delta G we need to get. How to get delta G? Delta G equal to minus 2.303 RT log K. Here log K is available. Log K given in the question. So we can find out delta G. So it will be minus 2.3 into R value, 8.3 into temperature, 500 into log K. Log K given 2.2. You get 2.2. This when you work out. What the figure you are getting is minus 21026 joules. Minus 21026 joules. Please verify that. Minus 21026 joules. See, this will be nearly more than 1000. Into this will be more than 2000 something. Into 8. It will be into the range 8.3. It will be in the range of 20,000. In the range of 20,000. Exactly, it's going to be minus 21026 joules. Okay. So that can be applied here. So you get delta H equal to minus 21026 plus 9,000. That means you will get nearly about, suppose it is in the kilojoules, 21 minus 19, nearly about 12 kilojoules you will get. 12 kilojoules, because it is 21 kilojoule, this is 9 kilojoule, it will be 12 kilojoule, and the value is nearly 12 kilojoule. This is going to be minus 21 kilojoule. This is 9 kilojoule. So it will be minus 12 kilojoule, either delta H. That means this is 12 kilojoule. This is 12 kilojoule. So 12 minus or plus or minus. So it is minus 12 equal to AB value 32 into 2, 64 minus A2 in the value 6 plus E value X. So it is minus 12 equal to 64 minus 6 minus X. 64 minus 6 minus X എന്ന് പറയുമ്പോൾ X equal to 64 ന്ന് 6 പോയാൽ 58 അല്ലേ. So it is 58. ഈ 12 ഇങ്ങോട്ട് വരും plus 12. You get 70. That is the answer. 70 is the answer. Right? So look at the way the question is presented. Delta, there are 3 components involving in a reaction A2, B2, AB. Adinde delta H value, that of AB given, A2 given, asking what is B2. And delta S of all the 3 components given, temperature given, and log K value is given. What is the procedure for working out? The procedure for working out, using log K, we need to find out delta G. Using this log K, we need to find out delta G. This we need to find out. Okay. Now, delta G equal to delta H minus T delta S. This we can work out. The data is available. Okay. So from which you can get so this already we have worked out. This you can calculate delta H equal to delta G plus T delta S. Right. And that coming around minus 12 kilojoule, either delta H. Right. So using log K value, we find out delta G. Once you get delta G and once you calculate T delta S, you can get delta H. And what is delta H formula? This is delta H formula, in which once you get this data, you can get this data, because these 2 data given. I hope it is pretty clear. right? On to next question. 41. For the reaction N2O4 giving 2NO2, graph is plotted as shown below. Identify the correct statements. First one, standard free energy change for the reaction is minus 5.4 kilojoule per mole. The standard free energy change for the reaction. You see the reaction A to B, that is N2O4, which is A, converted to 2NO2, which is B. Okay. A to B, delta G is minus 5.4. No, this is A, and this is B, and delta G is plus 5.4. A statement is wrong. It is not minus 5.4, it is plus 5.4. You see this? This is A and this is B. Look at the difference, A to B. It is plus 5.4, not minus 5.4. So A statement is wrong. A statement is wrong. Third statement is out. അടുത്തത്, as delta G in graph positive, N2O4 will not dissociate into NO2 at all. That is wrong. It's a reaction under equilibrium. It's a reaction under equilibrium. If this is positive means chance of getting the spontaneity of getting B is less. That's all. Anyway, it is under equilibrium. At the point E, it is under equilibrium. Under equilibrium means there is dissociation and association. There is a definite quantity of N2O4 available and NO2 available, right? So N2O4 will not dissociate into NO2 at all. It is wrong. This much it is dissociating, no? This much it is dissociating. So option B, statement B is wrong. Statement B is wrong. So analyzing first statement, we eliminate one choice. Analyzing second statement, we eliminate one more choice. Left with two more choices. Reverse reaction will go to completion. Reverse reaction will go to completion. No, reverse reaction will come up to this. This is the end point. It can't go to completion. There is an equilibrium. There is an equilibrium where delta G comes to be minimum. Equilibrium at E. So it is no point of talking completion. C is wrong. C is wrong, and we get our answer. Option 1 should be the answer. D and E, we haven't cross-checked, but we can confirm answer should be D and E first choice. Let us verify. Let us verify option D. Statement D. When 1 mole N2O4 changes into equilibrium mixture, delta G value is minus 0.84. When 1 mole N2O4 means A. When 1 mole A come to equilibrium, delta G is minus 0.84. Perfect. You look at this. A come to equilibrium. You can see this is point A. It is coming to equilibrium. You can see this is the drop, minus 0.84. That is perfect statement. D is perfect statement. Now E, when 2 mole N2O4 changes into equilibrium mixture, the delta G is minus 6.4. B comes to equilibrium. You see, this is A point. It's coming like this. This is B point, right? And you see this much. B comes to equilibrium. It's dropping here. How much it drops? It drops minus 5.4 and it drops minus 0.84. So what is the value? Minus 5.4 and 0.84. So it is minus 5.4, 0.84, 4, to 6 minus 6.24. Yes, that is also correct. Option E is also correct. When B comes to equilibrium, this much it travel, right? So it will be this much plus this much. And this is 5.4 and this is 0.84. So it will be decreasing by minus 6.24. That is also a perfect statement. Okay, a conceptual question asked on a graphical model. Of course, qualitatively and quantitatively, the question carry the important aspects of spontaneity of a reaction versus equilibrium. I hope it is clear. Only option D and E are correct. Okay, fine. അടുത്ത ചോദ്യം. Consider the following redox reaction taking place in acidic medium. If the Nernst equation for above balanced equation is available, what is N? So N factor is the question. N factor is the question. So we have BH4 minus plus simple question, right? ClO3 minus, you get H2BO3 minus plus Cl minus. When you analyze the oxidation state of various species, boron ഇവിടെ plus 3 ആണ്, boron ഇവിടെയും plus 3 ആണ്, no change. Hydrogen minus 1 ആണ്, and hydrogen here is plus 1. That is actually oxidized. So hydrogen undergo oxidation. Minus 1 to plus 1. So N factor will be 2 into 4 hydrogen ഉണ്ട് കേട്ടോ. So it is 8. So hydrogen is actually undergoing oxidation. Hydrogen hydride minus 1 is converted to normal proton H plus. Therefore, number of electron lost will be 2. There are 4 hydrogen, 2 into 4, 8 electrons. But that you can't give here. You need to check the total electrons. While here, chlorine is in plus 5 state coming to minus 1 state. So that in fact is reduction. Plus 5 to minus 1 പറയുമ്പോൾ 6 electron കിട്ടും, 6 electron. So reduction you have 6 electron, reduction you have 6 electron, and oxidation you have 8 electrons. So it will be so simple. 6 into 4, that is 24. 8 into 3, that is 24. So N equal to 24. N equal to 24, right? So boron, there is no change in oxidation state. What changes in oxidation state is hydrogen and chlorine. Hydrogen minus 1 ൽ നിന്ന് plus 1 ലേക്ക്. So N factor 2, 4 hydrogen 8. Okay. അടുത്തത് ക്ലോറിൻ plus 5 ൽ നിന്ന് plus minus 1 ലേക്ക്. N factor 6 ആണ്. അപ്പോൾ അവിടെ 6ഉം ഇവിടെ 8ഉം. When you equate, you get 24. 6 into 4, 24. 8 into 3, 24. Okay, fine. അടുത്ത ചോദ്യം. X and Y are the number of electrons involved respectively during the oxidation of I minus to I2 and S2 minus to S by acidified potassium dichromate. Value of X plus Y is. So let us figure out first one. K2Cr2O7 plus 2I minus, you get 2Cr3 plus I2. So here you have oxidation, N factor 2 കിട്ടും. minus 1 ൽ നിന്ന് 0 ലേക്ക്, N factor 2. Here plus 6 ൽ നിന്ന് plus 3 ലേക്ക്, that is reduction. N factor, hope you know it is 3 into 2, 6 വരണം കേട്ടോ. 6 വരണം, കാരണം plus 6 to plus 3, that is 3, but there are 2 chromium, അപ്പോൾ 6 എന്ന് വരണം. So N factor for dichromate 6 ആണ്, അല്ലാതെ തന്നെ അറിയാമല്ലോ. And then I minus to I2, N factor 2. So when you balance it, what you're going to get is ഇവിടെ ഒരു into 3 വരണം. So that it becomes equal to 6. So ഇവിടെ x എന്ന് പറയുന്നത് 6 ആണ് കേട്ടോ. x എന്ന് പറയുന്നത് 6 ആണ്. അടുത്തത് again we have the reaction potassium dichromate K2Cr2O7 with S2 minus. You get 2Cr3 plus sulfur. Once again, this is reduction and N factor is 6, and this is oxidation. Oxidation N factor again 2 ആണ്. Again same ആണ്. അപ്പോൾ രണ്ടും ഒരേപോലെ വരും. -2 ൽ നിന്ന് 0 ലേക്ക് 2 ആണ്. So net it will be 2 into 3 6. ഇവിടെയും 6. So y is also 6. So your answer will be 12. Your answer will be 12. X plus y is the answer. So oxidation of I minus to I2, the overall N factor in the reaction 6 ആണ്. That is X. And oxidation of sulfide to sulfur using potassium dichromate, again N factor 6 എന്ന് വരും. So the total answer, final answer will be X plus y. 12 എന്ന് വരും കേട്ടോ. Okay? Fine. അടുത്ത ചോദ്യം. 200 cc of X into 10 power minus 2 molar potassium dichromate is required to oxidize 750 cc 0.6 molar more salt solution in acidic medium. What is X? So here we have the reaction K2Cr2O7 in acid medium versus more salt. More salt means FeSO4 dot NH4 twice SO4 dot 6H2O. This is more salt, right? So the calculation is pretty simple. It is N1 M1 V1 equal to N2 M2 V2. Many times we have discussed in the classes, where N1, N2 are the respective N factors. What is N factor for potassium dichromate in acid medium? All of you know potassium dichromate in acid medium converted to 2Cr3 plus. So N factor is 6. So N1 equal to 6. N1 equal to 6. What about N factor here? More salt, very popular one. Everybody know in more salt, Fe2 plus will be oxidized to Fe2 plus. Fe2 plus will be oxidized to Fe3 plus. That is N factor 1. For more salt, N factor 1 ആണ്. Potassium dichromate acid medium N factor 6 ആണ്. അപ്പോൾ N2 equal to 1. That's it. 6 into molarity X into 10 power minus 3. X into 10 power minus 3 into volume 200. 200 equal to 1 into molarity 0.6. 0.6 into volume 750. എന്ത് വരും? 750 ഈ 0 കട്ട് ചെയ്താൽ 6 എന്ന് വരും. ഇത് ക്യാൻസൽ ആവും അല്ലേ? നൗ ഇവിടെ ഇത് കട്ട് ചെയ്താൽ 0.2 ആയി. സോ എക്സ് ഇൻറ്റു 0.2 ഈക്വൽ ടു 75 എന്ന് വരും. എക്സ് ഈക്വൽ ടു 75 ബൈ 0.2, ദാറ്റ് ഈസ് 750 ബൈ 2. 750 ബൈ 2 എന്ന് പറയുമ്പോൾ 375 അല്ലേ? ദാറ്റ് ഈസ് ദ ഫൈനൽ ഫിഗർ. 375, ദാറ്റ് ഈസ് ദ ഫൈനൽ ഫിഗർ. 375, that is the final figure, right? Yes, the simple application N1 M1 V1 equal to N2 M2 V2. You must know what N factor is. ഓരോന്നിൻ്റെയും N factor അറിയണം. പിന്നെ ഒന്നുമില്ല, നേരിട്ട് അങ്ങ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. പൊട്ടാഷ്യം ഡൈക്രോമേറ്റിന്റെ N factor 6 ആണ്. ബിക്കോസ് ക്രോമിയം പ്ലസ് 6 ചേഞ്ചസ് ടു ക്രോമിയം 3+. അപ്പോൾ ഒരു ക്രോമിയത്തിന് 3 എന്ന് വരും, രണ്ട് ക്രോമിയത്തിന് 6 എന്ന് വരും. Ferrous ammonium sulfate, that is more salt. The active species undergoing oxidation is ferrous. Ferrous ferric ആയിട്ട് മാറും. അപ്പോൾ അടുത്ത n factor 1 ആണ് കേട്ടോ. So just substitute and find out the answer. And this is a formula quite frequently we were making use of. Okay, that's it. അടുത്തത്, the oxidation state of chromium in the final product formed in the reaction between Ki and acidified potassium dichromate is acidified potassium dichromate. Acidified potassium dichromate, you will get 2Cr3 plus oxidation state of chromium in the final product plus 3. Nothing more than that. It is plus 3. Second choice is the correct answer. Plus 3. Right?